Let's start. It's not good morning. Then I will upload that note to the LMS. Did you see that? I uploaded to that LMS yesterday, okay? Did you see that? No? Okay. Then this is the way we can do the descriptive analysis to the data set, okay? Then there are, I took the two examples, okay? Then descriptive statistic means we do the data collection, organizing and presenting. Okay. Then measurements we call as the summary measures we can use in the descriptive statistic part. Okay. Then this is the data set. This following data set reflect the service ratings on the scale 1 to 10 from 15 customers. Okay, this is the small data set. Okay. Then the sample size is 15 customers. Then they collect the data from the customer for the service ratings. Then their service, then the customer satisfaction. Okay, then their rating. Then there are 15 customers are there in their ratings, 1 to 10. Okay, then customers give the number. Okay, then their satisfaction. Then this is the analysis of that. Okay, then we can do that analysis using our Excel. Okay, then the Excel is the you can use. Then we do that one. In Excel, one to 5, 15. Yeah, then using the Excel, we can do this analysis part. Okay. Can you see? No? I can't control it. Okay, then in here. Yeah. Okay. Okay, then this is our data set. Then we in here, their data tab we call data. Okay. Then there is an analyze part in here. Okay. Then this is normally not in the Excel. Then we can add it. Okay. Then there is a called addings. You can add anything. Okay. Then in here data analysis part in here. Okay. Then we move into the data analysis. Then first we select which tool we require. Okay, then we need to take the descriptive statistic part. Okay, descriptive statistic now you know. Okay, then statistic is there are two different parts, descriptive one and the inferential one. Okay, then we need to do the descriptive statistic. Okay, then we okay. Then the first one is ask input range. Okay, then we can select this is our input. Okay, then group by. Then how to group by in here? Column wise now. Okay, then we select the columns. Then we insert what is our output range. Then we need to take the output in here. Then we need to take the summary statistic. Summary measures. Okay, then we can move to the OK. Then we can take the values in here. Sorry, then in here take the ID values. Okay. Only we insert our ratings only. Okay. This is the data set. No, other one is customer ID. Okay. Then this is our descriptive analysis. Then you can get that. Okay, easily you can get the analysis using the Excel. Okay, understood how to do that? Okay, then we have the mean value, median value, mode, standard deviation, what is the variance in here, range, maximum value, minimum value, okay, count, okay, sum of the observations value. Okay, you can get all the things regarding the descriptive analysis. Okay, then you can want to insert the graph. You know, no? Already you know, no? How to get the graph. You can insert the bar graph or pie chart. Okay, then you can do that. Okay, that is part we called as the descriptive analysis. Okay, then in here, there is only one variable. No? There's customer satisfaction. Okay, then normally in the data set, we have lot of variables. Okay, then we identify what is the type of variable. It is a categorical variable or the quantitative variable. It is a numerical variable. Okay, then first identify the type of the variable and the level of measurement. Remember levels of measurement? Yes or no? First lesson we discussed, no? Okay, then there are 4 levels of measurements: nominal, ordinal, interval, and the ratio. Okay, in here there is a customer satisfaction. Okay, then their customer rating their service satisfaction. Then this is a which level of measurement in here? Nominal or ordinal or interval or ratio? Which one? Which one? Last week I said no. Can't remember. Nominal one means what? Then this kind of variable only we can label it. We cannot do any further calculations. Now, okay. Now remember. No. Gender, marital status, then those kind of variable only we can label it. Okay, then we can identify which respondent is a male or female. Okay, then their marital status, married, unmarried, widowed, or something. Okay, then only label. We cannot do any further calculation. Okay, only we can get the count. How many male respondents are there? How many female respondents are there? Okay, and remember. Then ordinal one means what? Ordinal. Ordinal. This kind of variable we can order this. Okay, then we can get the count, we can label it. Other thing is we can order it. Then level of education. Then we are from our respondents their level of education. Okay, then according to their level of education, we can order them. Yes or no? Yes, no? Okay, then their seniority level. Okay, then they say they are junior or senior or something. Okay, then we can order it. Okay, then these kind of variables falling into the ordinal level scale. Okay. Then the other one is interval. Interval. Then interval scale measurements, we have all the features in the ordinal one. Maybe in the interval level scale variables, we can label it, we can note. What is the special one? Then we can do the addition and the subtraction using the interval scale variables. Okay, then the example, temperature, date, then those kind of things falling into the interval scale. Okay, then the temperature, we can take the summation or subtraction. Using the data, then think someone asked the question from the respondents, what is your birthday? Using the birthday, we can calculate the age as a today's date. How to do that? Take the today's date minus his or her birthday. Then we can take the age as a today's date. Okay, then we using the subtraction. Then these kind of variables falling into the interval scale. Okay, then the ratio one. We can apply all the mathematical operations to the ratio scale. Okay, then we can do the addition, subtraction, division, multiplication. Okay, normally in the ratio scale variables, there is a numerical variable in here. There is someone of age, there are monthly income, monthly expenditure, okay, then marks of the particular subject. Then those are, we can use any mathematical operations. Okay, then we collect the marks for the statistics subject in this group. Then we take the marks value and we can calculate the average mark. How to do that? Add all the marks and divide it by number of students in here. Okay, then we apply addition and the division. Okay, then we can apply all the mathematical operations to the ratio scale variable. Okay. Now remember. Okay, then we firstly identify in our data set what kind of variables in here. Okay, then next important thing is identify what is the appropriate level of measurement. Okay, then we need to do the analysis using the SPSS. Okay, then first create our data views. Okay, then that software asks what is the level of measurement. Okay, then first we insert their reference number. Then they ask what is the level of measurement. That's a compulsory to enter the level of measurement. Then reference number, we cannot do anything using the reference number. Okay, then in their questionnaire, there is a reference number only to identify. Okay, then we cannot do anything using the reference number. Then that kind of variable falling into the nominal scale. Then we insert nominal. Okay. Then other one asks their education level. Okay, then only we can do the order. Okay, then we insert the ordinal scale. Okay, then in the SPSS, then using the software, then they identify only 3 categories of level of measurements. They are nominal, ordinal, and the ratio. Normally, they do not take the interval. Okay, then the only label it, they take it as a nominal one. Okay, then we can arrange in that kind of variables. They take as a ordinal one. All the things they consider as a ratio. Okay, then other thing is questionnaire, through the questionnaire we ask their income level directly. Then the respondents will write their number value in here. What is the income? They say 1 lakh or 2 lakh or something. Okay, then using that data, we can do any analysis. Using that value, we can calculate the average value. Okay, but then in that way, then we can consider their monthly income ratio scale. Why we can apply any mathematical operation. Okay. But then through the questionnaire, then we ask their income level. Then ask the income level. Then we suggest some answers. Then the more than, then less than 1 lakh, 1 lakh to 1.5 lakh. Those way. Okay, then the respondents tick. But then they are range of the income. Okay, then that type of questions, then we consider as the ordinal level. We cannot take as a ratio. Why? Then we have only categories, no? Okay, then we cannot do any further analysis. Using the categorical responses, only we can order. Okay, then that is the way we consider as the ordinal. Remember? Okay, then first you identify what is the variable, then you think about what kind of questions we ask to get the idea about that particular variable. Okay, what's the type of question? It's clear? Sure? Okay, now. Okay, then don't memorize it. Then the income level, that's the ratio. See, that's wrong. Okay, the income level you directly ask, then it is the ratio scale. But we are there's a time to given.
Target speed and not target speed is like what time stay with it. If looking for the train.
Okay. I will go through your lessons, okay? First to grade 1. Okay. Then we can do the descriptive analysis. Okay, then the first you identify what's the variable. Okay, then what are the response from that variable. Okay, that's important. Then based on that, we can do the analysis. Okay, then we have numerical type of variables, quantitative variables. Okay, then we can draw the bar graph, pie chart, those kind of things. Then in here is their data type is customer satisfaction. Then they are give their ratings. Each customer gave their ratings. First customer gave 3. Second customer gave 5. Okay, then their ratings level. Then they tell me which type of level of measurements regarding this variable. What is it? Nominal, ordinal, or ratio? Then we can label it this data. Okay, we can identify. Then we can arrange the order. Okay. Then we can use any mathematical operations to calculate it. What is the level of measurement? Yeah. Ratio we can take. Normally we can say as a ratio, but it specifically it is the directly from the ordinal, but we can take that arrangement only. Okay, but we can do the descriptive analysis part, then we can calculate some measures. Okay, normally this is calling the qualitative one. Okay, then understood that we take the customer satisfaction. Okay, then we have mean, median, mode, those things. But then which one is the very appropriate to this data? Mean, median, or mode? Normally, in the qualitative kind of variables, normally we use more. That is a very appropriate to the data. Then we can calculate. Normally, then the qualitative type variable, we use the mode as the central function. Then we can say the most number of customers there, then their rating is this one. Okay, then that is the meaningful thing. Okay, then in here mode value is 5. And we can look in at this data set. 5 is the most frequent number in here now. Do you know about the mode? Remember, mode most frequent number. Okay, then go through this data set. Which value is most frequent one? 5. Okay, then the 1 to 10 rating means average is the 5 no? Okay, then the most number of customers say their customer service is rating as 5. The average. Okay, then we have mean value is 5.8, median value is 6. Median means we arrange this data set in the ascending order. Then what is the middle? Okay, then we can calculate the mean, median, mode 3. Okay, easy. No worry, then what? What is the appropriate one? No. It's clear now? Okay, then we collect the data of their rating marks. Okay, then now exams are finished on some batches, then we think financial mathematics subject. We collect the data for the marks of each student in particular group in 10. Then we have the marks. Then these are the quantitative variables. Marks. Okay, then their level of measurement is ratio. Okay, then we can do the mean. Right? Normally we can say no, the average mark is 65 or 66. We can say no, that's a meaningful thing. Okay, then we can say then think they are not value is 65, no, 55. Then we can say most number of students got the 65. Sorry, 55. Okay, the median is not meaningful. Median is a middle one. Okay, then we change the marks value. Then arrange it as ascending order. That's the middle value is this one, median. And then in that case, we can use the analysis to use the mode and the mean value. It's mean. Understood? Now, okay, then we can take the standard deviation, variance, measures of dispersion. How to variation is there? Variance. Okay, then the standard deviation is high. Then we can get the higher value. We can say they are higher variance. Okay, then we conducted the exam for the financial mathematics group 2 intakes. Okay, then we can take the which measurement to compare these 2 intakes. Last week session. Which measurement appropriate to compare these 2 intakes? Yeah, coefficient of variation, CV value. Coefficient of variation means standard deviation and the mean. We can take the ratio of the mean and the standard deviation and the mean. Standard deviation divided by mean, we call that coefficient of variation, CV value. Then in intake 1 and intake 2, okay, then intake 1 their CV value is 23%. Then intake 2 their CV value is 30%. Then which group is more consistent? 1 or 2. Intake 1 they are 23%. Intake 2 30%. Then which intake the more consistent? 1 or 2? 1. Why? Then we compare in the 1 and 2. Then the CD value is less in the intake 1. Okay, then the coefficient of variation is less, means their variation is less. Okay, then the variation is less means there is a more consistency than the intake 2. Then in the intake 2, then their CD value is high, means what? Then their variation is high. Then we can say their variation is high means their consistency is lesser than the intake 1. Okay, then the which group is the best now? Intake 1 or intake 2? Intake 1, their consistency is high. Okay, then all the students are in their knowledge level according to their financial mathematics is there. Consistency is high. Okay, now remember, then this is the way we can analyze the descriptive. Okay, then using our data set. Okay, then we can, then there is the second lesson, then we do the presentation of the categorical variables. Then we discuss different kind of graphical methods. Okay, then we can identify our type of variable, then we can choose the appropriate graphical method to represent the data set. Okay, then we have the data set according to the time series thing. Okay, then we collect the data for the particular company 2010 to 2020. Okay, then there are sales revenue. Then which graphical method we can choose to represent this kind of data. Then time period. We use the line graph. Okay, then line graph is a very suitable tool to represent the time series analysis. Normally we use the line graph. Okay, then we have the categorical data set. We can use pie chart or graph, bar chart. Okay, then we can use any bar chart, simple bar chart, multiple bar chart. Then we have more than one categorical variable in here. We do not use a simple bar diagram. Then we can use a multiple bar diagram, subdivided bar diagram. Okay, percentage bar diagram. Then you can use. Okay, then this is the way we can analyze in the descriptive way. Okay, then this is the way we can analyze our data set using the Excel, only descriptive part. Okay, then you all of you know how to insert any graph. In here there is a recommended graph and the charts. Okay, then first you identify what is our type of variables, then we can insert the particular chart. Okay, then we insert the chart into our report. Okay, then what are the compulsory things? First, you insert the topic, okay, title for the chart. Okay, then which data set represent through this chart? Okay, then another one. Then we use the different type of color. Then we can insert the key. This color represent this one. This color represent this one. Okay, then we construct the bar diagram or line graph. Okay, then we label the two axes. Okay, then this horizontal axis represent this one. Then the vertical axis represent this one. Okay, then we label the two axes. It's clear? Then we can do the, using the Excel, we can do automatically, we can add the title, we can add the by X and Y line titles, those things. Okay, then these are the very important things. We need to write the report, do the descriptive analysis, we insert the chart. These are the mandatory things. Okay, then we can move into the quantitative analysis, descriptive analysis using the summary measures, measures of dispersion. Okay, then we can write the report. Okay, then the first assignment for you, that one. Okay, then select the data set and do the descriptive analysis. Okay, then I will upload the guidelines to the LMS next week. Okay, how many weeks do you need to do that? Choose the small data set. Take the only moving. Do not use the ChatGPT. Okay. And ChatGPT that one then. So the one that you have more words than the idea. Search. You can then watch seven people. So it's enough. Then I will upload the guideline to tell them based on Monday. Monday is 25th. No? Then before the hour, you have to be up. And I'm out of the running with the okay. And the date is 8th of April. Okay, that's the deadline. Yeah, only you write the 2 pages enough. Okay, one and a half. Okay. Okay, you write something. Okay, then I can understand your level. No? Then if you understand it, subject or not. Okay, then select all this small data set. Okay, you can write anything about regarding the descriptive analysis part. First, write the paragraph about what is the data set. Okay, that's important thing. Okay, then why these data collected, what is the objective. Okay, then you write, then you present, then you select the which chart type is suitable to present this data. Okay, then it is depends on your data set. Then you collect the data for the time periods. Then you can draw the line. Then you can draw the charts using the Excel. Okay, so okay. Then you have the categorical type of data. You can specify chart over. Okay, then you have the data set according to the quantitative kind of. You can use in the bar graph history. Okay, you can use the appropriate chart based on your data set. Okay, then you can do the descriptive analysis. You can calculate the sample measure. Okay, central segment measures and the measures of research. Okay, you can use it like that. Then you can take this part. Okay, then you go to the Excel and you add in this tab. Okay, data analysis. That is that one to one. Okay, then you can take it out and the manually calculator and go to the okay. If you have any problems regarding the assignment, please contact me before the end of it. Okay, then I will upload all the guidelines to the area. Then you select the data set in here, then we take the sample to 80. Okay. Then this example in here, then we calculate the mean value in the 5.8. That is the average rating. Okay. Then the mean, then 6 is the median one. Then the very important thing is what? Mode in here. This is a qualitative type. Their customer satisfaction. Okay. Then they give their ratings value. Okay. Not the marks value in here. No. Then the most frequent rating is the 5. Okay. It appears 3 times in here. Then we can express as the standard deviation variance in here. Normally, then when you select in the data set, you select the quantitative one. Okay, sales revenue or their advertising expenditures, those kind of things. Then you can do that easily. Okay, then you take the select any company, then there are 2 or 3 outlets, then you can take the sales revenue. Okay, for the 10 periods. Okay, then you have the separate 3 data set now. Okay, you can do the comparison in between the outlets. Then you select someone, XY company, then there are 3 outlets, A, B, C. Okay, then you take the 10 periods, then take in the sales revenue for the 10 periods for the 3 outlets. Okay, then you can compare. No? Then this is the mean value in this outlet A, then this is the B, this is the C. Then you can calculate the coefficient of variation and you can write it about their consistency of the sales revenue. Okay, then this is the very easy. No? Then you can take the sales revenue or advertising expenditure or their profit. Okay, then quantitative type of data, numerical one. Okay, then these data set are falling into the ratio scale. No? Okay, then using the time period, you can do the line graph. Okay, then using the multiple bar chart, then you can compare. No? Okay, then this is the sales revenue for the first year A, B, C. Then you can choose the multiple bar, those things. Okay, now okay. Then first outlet, there are 3 products. Okay, then you choose only one outlet and take their sales revenue for each product. Okay, then you can take the large data set. Now, okay, you choose only small data set. Okay, not choosing the large number of data in here. Then you choose the small data set. Okay, now clear? Okay, you do that. Then in here there is an example number 2. Then this sample data set has test scores on 4 placement tests. They conduct in the test and they collect the data, collect their scores value English, reading, maths, and the writing. We want to compare the summary statistic of these 4 tests so we can determine which test the students need to do the best and worst of. Okay, then their students' level of the knowledge. Okay, then we take the descriptive part. Then we can say English, then their maximum values in the English and readings. What happened? Their maximum value is more than 100. Okay, 101 and 103. Can we get or can't? Normally in the exam, then they give the marks for the out of 100. No. Okay, then but our in output, their maximum value is more than 100. Okay, can't we get? No. Okay, then we can say there is a problem in our data set. Okay, not for the error of the software. No? Then we input, then we take the data, then we collect the data and we enter our Excel sheet or any software. Then we have any problem to insert our data into the data sheet. Okay, then we can identify if there is any problem. Okay, then we can identify their minimum mark and their mean value in here. Okay, then we can calculate the using the mean value and the standard deviation, and we can calculate the CV value for the 4 subjects. Okay, then based on that, we can say which subject is the more consistent. Okay, it's clear. Then there are 4 subjects in here, means 4 groups are there. Then this is the regarding the English, this is the regarding reading, this is the regarding maths, and this is the regarding writing. Then we can calculate the CV value of each category. Then we can identify their variation, then their consistency. Okay, this is the way we can write the descriptive analysis. It's clear now. Okay, then this is your assignment number 1. Okay. You have any problems regarding the assignment? Then you can ask now. I will give 5 minutes. Now let's start our lesson. Okay, then we finish our descriptive analysis part. Then we move into the probability. Okay. Then the first one, in the part 1, we discuss about the probability concepts. Okay. Okay. Then the objective of this session, introduce the basic concepts of the probability, and we define the different kind of probability approaches and the concepts. Okay. Then these are the learning outcomes. Okay. Then first we move into the probability. All of you know about the probability concept. Okay, then we have not 100% chance to happen something. We call as the probability. Okay, then that in the definition is the probability is always provide the numerical measures of the uncertainty. Okay, so this probability we discuss about the uncertainty. Okay, do you know about the uncertainty? You know uncertainty. Okay, then there is no any chance of happening. That one is at the 100% sure. Okay, that we call as the uncertainty. Then probability means that provide the numerical measure of the uncertainty. The statistics subject always we find out the numbers. So then we dealing with the numbers only. Okay, then we do the analysis using only numbers. Okay, then therefore we can take the probability is the numerical measures of the uncertainty. We measure it. Uncertainty is the probability, then we measure it as a numeric. And then we take the value. Okay, then these are the examples. There is a 30% chance that this job will not be finished in time. Okay, then there is a 30% chance. Okay, then there is a every likelihood that the business will make a profit of the next year. Okay, then think there is a 20% chance, okay, that the business will make a profit. And 20% is uncertain. And that's the numerical measure of the uncertainty. Okay. Then this third one, 9 out of 10 he arrives late for his appointments. 9 out of 10. That is the numerical measure of the uncertainty. Okay. Okay. Then other one is the numerical measure. A numerical measure about the uncertainty we call as the probability. Then these are the values we can get the probability. Okay, normally the value range of the probability is 0 to 1. Okay, we cannot get the negative value for the probability of that particular value. Cannot be get the negative value and cannot be get the greater than 1. Okay, then within range is 0 to 1. Okay, then it means we can get the decimal value for the probability fraction. Okay, proper fraction. There is improper fraction and then some other fraction means that we can get only the proper fraction. Okay, then 0, then we can take the probability value is 0. It means what? Impossible. Okay, then we can get the 1. We can get the probability value as a 1. What is the result in here? There is no any uncertainty. That's a certain. Okay. Then we can get the half. It means even chance equally likely. Half. Then we toss a coin. What is the probability of getting head and the tail? There is equal chance. Okay, maybe getting a head or getting a tail. There is equal chance. Their probability value is half, 0.5. Okay. Then likely and likely, then the probability value is, okay. Then moving to the 0, then there is a not likely that event. Okay. Then the greater than half and approximately to the 1, then there is a more chance to happen. Okay. Then this is the representation of the probability values, numerical values. Okay. Then always we get the probability value 0 to 1. Here we cannot get the negative values and we cannot get the more than 1. Okay. Then in the probability lesson, then there are three definitional perspectives of the probability. Okay, now you know probability is the numerical measure of the uncertainty. Then the first say, classical definition of the probability. It means we do not do any experiment. We can say what is the probability. Okay, then please toss in a coin. Okay, we can directly say no. Get in a head. What is the probability value? 0.5. Get in a tail. We can say 0.5. We cannot do any experiment. Okay, then conducting the experiment is not important to express the probability value, that kind of. Okay, then based on the past experience, then we can say this is the probability. Okay, if the process generates the outcomes is known, probabilities can be deducted from the theoretical arguments. Okay, then we say the probability value based on the theoretical argument. We call that the classical approach, classical definition. Okay, then how to say the half is the probability of the getting ahead. Then there are two outcomes in here, head or tail. Getting ahead only one chance out of two. Then 1 over 2 is the probability value. We can say no, that is we call as a classical approach. Everything rolling the dice. Okay, then rolling the dice. How many outcomes we can get? 6. 1 to 6 number. Then getting a number 1. How many chances is there? How many chances? Then first rolling the dice. Okay, then we need to get a number 1. Then how many chances is there? Only 1 chance. Okay, then total number of outcomes is there 6. Then the 1 over 6 is the probability value getting a number 1. Okay, then we need to getting a even number. Okay, then we can say the probability value in the dice there are 1 to 6 numbers. How many even numbers is there? 3. Okay, 2, 4, 6. Then what's the probability? 3 over 6. There is only 3 chances getting the even number. Okay, then we need to take the value greater than 4. How many chances is there? Only 2. And by 5 and the 6. Then we can say probability is the 2 over 6. Okay, then we can express the probability value of the particular event based on the theoretical argument. Okay, there is a theory behind that, no? Okay, then getting an even number, then there are 3 chances. Okay, then total outcome is 3. We can say 3 over 6. Okay, then getting a more than number 4, there are only 2 chances. We can say 2 over 6. Based on the theoretical arguments, we express the probability that we call as classical approach. Understood? Okay. The next one is relative frequency approach. Okay, then that is the opposite of the classical one. We can say in the relative frequency approach, then we must conduct the experiment. Okay, that's the compulsory thing. Based on the experiment, we express that is the probability. Okay, then using the relative frequency approach, we cannot express the probability based on the theoretical arguments. Okay, then we need to take the probability value of the getting a defective items in our production batch. Okay, then first we conduct the experiment, identify how many defective items are there. We cannot express the probability value based on the theoretical arguments. We can't say no. Okay, then they think we have the 1,000 number of products in the one batch. Okay, then first take the 10. Okay, then first select the 10. Always do the sampling process. First take the 10, then we identify how many defective items are there. Okay, then we write it. Then take the 20 number of sample units. Then we check with how many defectives are there. Then we take the 50. Then we take the 100. Okay, then we do this process continuously. Okay, then we identify in that different samples how many defective items are there. Okay, finally what happened? Then their rate of the defectives is approximately similar. Okay, then first one is 2 over 10, 0.2. Then next time 0.3, 0.5, 0.5. Then 0.5152. Then 52, 52, 52. Okay, then we do that experiment continuously. Then what happened our output? Approximately similar probability value. Okay, then based on the experiment, we express the probability we called as what? Relative frequency approach. Okay, based on the empirical data, we can express the probability. Okay, it depends on the repeatability of some process, ability to count number of repetitions, and number of times that the event of interest occurs. Okay, then do that process, repeat it. Okay, then we conduct the repeatability of some process, then we can get the probability value of the particular event. Understood? That we call as the relatively frequency definition. Other one is subjective definition. Okay. Then there is no any theory behind the subjective one. Then we can express the probability value based on our experience, our knowledge, okay, our qualifications, those things. Okay, then we take the previous example. We need to take the probability value of getting a defective item or defective rates. Then we ask from the quality supervisor. Then they say their idea. Okay, then 20% of chance. Then 20% of the defective rates in here. Okay, then they say, then he or she said that one based on their experience. Quality supervisor. Okay, then we move into there is a quality manager. Then they ask from him. Okay, then they say 30%. Okay, then he or she said that based on their knowledge. Okay, understood? Then what happened our probability value? We can get the different value for that event. Okay, then we call it as the subjective. Okay, then it depends on the judgment and the experience. Based on the experience, based on the education level, okay, based on the knowledge, we can express the probability value. Understood? Then I ask probability of that particular event. Okay, then we can get the different answers. Why? Then your answer based on your experience or knowledge. Understood? It's clear? Okay. Then derive from an individual's personal judgment or own experience about whether a specific outcome is likely to occur. Okay, then always we express the probability using the subjective approach based on our personal judgment or our experience or our knowledge. Understood? Now clear? Then the probability is the numerical measure of uncertainty. Then there are three perspectives where we can define the probability. First one is classical approach. Classical means we based on the what? Theoretical arguments, we can express the probability. Okay, we can prove it always. Okay, then getting ahead is a probability value is 0.5. Okay, we can prove it now. Then there are total outcomes is 2. Then how many chances for the getting head is only 1 chance. Then we can say 1 over 2 is the probability of getting a head. It's clear? Then always we express the probability based on the theoretical arguments. Okay. Then next one is relative frequency approach. Then there must we conduct the experiment. Okay, we conduct the repeatability process and we can identify the what is the probability of that particular event. That is based on the empirical data. Okay. Then the third one is what? Subjective definition. Okay, through this subjective approach, we express the probability based on our personal judgment or knowledge. Okay, then first two theories, then first two approach, the probability value of that particular event may be same. Okay, then we calculate the probability of getting ahead. Okay, then in here think where there are 10 students in here, then all the 10 answers are equal. All of you say half. Okay, then the relative frequency approach we can get same. Then we conduct the experiment and we same. But in the subjective approach, what happened? We can get the 10 different answers. Why? Then we express the probability value based on our personal judgment. Oh no. Understood? Now clear? Then these are the three different kind of perspective of the probability. It's clear? Okay. Then we move into the some subject related words in the statistic regarding the probability. Okay. First one is we need to identify what is the experiment. All of you heard that word, experiment. Okay, then experiment means what? That's the process in result of any outcome. Okay, then we conduct the experiment. Why? What is our objective? Getting outcome. That is the experiment. Okay, then what is a random experiment? Experiment and the random experiment. What is a random experiment? Random experiment, we know the outcomes. Okay, then toss in a coin. Okay, all of you know about what are the outcomes? Toss in a coin, head or tail. Okay, but we cannot predict which outcome can we get now. Can or can't? We cannot. That kind of experiment we called as random experiment. Okay, then already we know what are the outcomes. Okay, but we cannot predict the outcomes. Okay, we can get at now. Okay, then before tossing a coin, we know we can get a head or tail. Okay, then after the toss a coin, okay, only we can identify which outcome we can get. Understood? That we called as a random experiment. Okay, then when the outcomes cannot be predicted with a certainty, then the experiment we called as random experiment. Already we know the total outcomes, but we cannot predict the outcomes with the certainty. Okay, can we get now? Before tossing a coin, we cannot predict which outcome can we get now. Okay, then before tossing a coin, we cannot say 100% surely we cannot say we can get the head or tail. Okay, we do not know any outcome can we get. After the tossing a coin, we can say we got the head. Understood? That kind of experiment we call as random experiment. Okay, in the probability concept, we use random experiment. Okay, then we get the results of the random experiment we call as outcome. Tossing a coin is the random experiment. What are the outcomes in here? Head or tail. Rolling a dice is a random experiment. What are the outcomes? 1 to 6 numbers. Understood? It's clear? Okay. Then other one is very important thing is sample space and the sample points. Sample space means all the possible outcomes of the any random experiment we called as sample space. Rolling a dice, what are the sample space in here? What are the all the possible outcomes? 1 to 6 numbers. Okay. Then normally in the sample space we denoted by S. Okay. S sample space no S denoted by. Then S equal within the curly bracket we write the all the possible outcomes. Okay. Then within the curly bracket we can write. Then S denoted by the sample space, curly bracket, open. Then we can write our all the possible outcome that we called as the sample space. Okay. Then the other thing is elements of the sample space we called as sample point. In here, how many sample points? 6. Okay. Then in here, there are 6 sample points. Okay. Sample points means elements of the sample space. Okay. Then this is the example. Okay. In a throwing a die, the sample space is 1 to 6 numbers. Already you know, no? Then in here, there are 6 possible outcomes. Then in drawing of 2 dice, what is the sample space? Then first one express the throwing only 1 die. Okay, we rolling a 1 die. Then what is our sample space? 1 to 6 now. We rolling a 2 dice. What is the sample space? Then how many sample points in here? 36. Why? Then we can say first one is get 1 and second one is also get 1. So 1 sample point. Then other one is 1 and 2, 1 and 3, 1 and 4. We can write now. Okay, then rolling a 2 dice, one has a 6 possible outcomes, other one also has a 6. Then 6 into 6, how many sample points? 36. It's clear? Then first we roll it, then tossing a 2 dice, rolling a 2 dice, then what happened? Then both can get the 1. Both can get the 2. Then one can get the 1 and other one get the 2. Then these are the sample points. It's clear? Okay. Then we move into the other one is event. Event means now you know the random experiment and the sample space. Okay. In the sample space, we insert all the possible outcomes. Then any collection of the outcomes we called as the experiment. Then think, our random experiment is rolling a dice. Okay, 1 to 6 numbers. Then we want to get the even number. Okay, then we need to identify getting an even number. Then what are the outcomes? 2, 4, 6. It's a collection of the possible all outcomes. Collection of the outcomes in our sample space. Then that we called as what? Event. Okay. Then our sample space is 1 to 6 numbers. Okay. Then we identify the event called getting an even number. Then we denoted by capital A. Okay, event A is a getting an even number. What are the even numbers? 2, 4 and 6. Okay, event means what? Any collection of the outcomes. Getting odd number. 1, 3, 5. It's a collection of the any possible outcomes. We call that event. Okay. Then this is the example. Here is sum of the numbers shown by 2 dice is odd. Okay. Then in here we have no sample space in the rolling 2 dice. Okay. Then first one are getting a sum is odd. Odd means you know odd numbers. Then we identify which sample points get the sum of the odd number. Then first one 1 plus 1 2. That's the even number. We cannot get. Second one 1 plus 2. That is 3. Sum is 3 now. Then we can take as an outcome. Okay, normally odd number plus even number. What is the final answer? Odd. Okay. Then we took this one. Then we can write the one. A is the sum of the numbers shown by 2 dice is odd. Then these are 1, 2, 1, 4, 1, 5. There is so many things. Okay, then we can write it. It's clear? Then sum of the 2 dice is 7. Okay, then we took the sample space. Then we identify which sample point get the sum of the 7. Then these are we called as events. Okay. Then before moving to other, okay. Then other one is, then now clear, theoretical part is clear now. Okay. Then rules of the event operations. Okay, normally in the mathematics, we have the mathematical operations. Addition, subtraction, division, those things. In the probability and the statistic, there is operations. Okay. Union, intersection, and the complement. Okay. Then the intersection, what we call is the intersection. Common thing. Okay. That we called as the intersection. Then there are 2 events. Then we identify, are there any common elements? Okay. There are any common elements we called as intersection. Okay. Getting an even number and getting odd number. These 2 events has the intersection or not. Getting an even number and getting an odd number. Are there any intersection or not? No. Why? There are no any common elements. Getting an even number 2, 4, 6. Getting odd number 1, 3, 5. There is no any common element. We can say there is no any intersection. Okay. Then we can say odd numbers and numbers less than 4. Odd numbers 1, 3, 5 less than is 1, 2, 3. In here 2 numbers in the comma. Okay. Then in here what is the intersection? 1 and 3. Then union means what? All the outcomes in the all events. Okay, then in here, A is odd numbers, B is numbers less than 4. Okay, then we need to take the union. We write all the outcomes in the event A and event B. Event A 1, 3, 5, B is 1, 2, 3. Okay, normally we write the sample points. We do not write the repeated. Then in here 3 is twice now. Then we write only 1 time. Okay, that we called as the union. Then how to express the union sign in this way. Okay, intersection is this one. Then other one is complement of an event. Complement means, then think we need to get the complement of event A. Okay, complement of event A means containing all the elements of the sample space, but these elements are not included in the event A. In here, event A is odd numbers. No? What are the odd numbers? 1, 3, 5. Okay. Then we need to write the complement of event A. Okay. Then we looking at our sample space. In here, what are the elements in the A? 1, 3, 5. What are the remaining things? 2, 4, 6. That we called as the complement. Okay, complement means these elements are not included in the A, but these elements include in the sample space. In sample space, 1 to 6 numbers. A is even odd numbers, no? 1, 3, 5. Then we cannot write the 1, 3, 5. Then we write other remaining things, but these are included in the sample space. 2, 4, 6. That we call as the complement. Complement we denoted by dash, A dash. Complement of B, we can write B dash. Okay, then we can write, what is this? Complement of the intersection. Okay, it means we write the elements that are not in the common elements, but these elements are included in the sample space. Then in here, intersection is 1 and 3. No? What is the complement? What is the complement element? 2, 4, 5, 6. Okay, then these are not included in the intersection. Okay, but these elements are included in the sample space. That we called as the intersection. Okay. Other two concept is, this is very important, collectively exhaustive. Collectively exhaustive means we take the union value. Now you know the union, no? All the elements in the 2 or more events. We need to take the A union B. It means elements are included in the A and B. Okay. Then collectively exhaustive means, then think sample space is 1 to 6 now. Okay. A is even now. B is odd now. Okay. Then what is the A union B? What are the elements in the A union B? 1, 2, 3, 4, 5, 6. Then what happened? Sample space and the union are same. Okay. That we called as a collectively exhaustive. Okay. Then we take the union that is equal to our sample space. We called as collectively exhaustive. Understood? Then A and B are collectively exhaustive. Why? A union B is equal to our sample space. Understood? Union, we write the union that is express all our sample space, we called as collectively exhaustive. Okay, A getting an even number, B is getting odd number. Then we write it as the union. Okay, in the union, we write all the elements in the sample space. No? Then that is the way we can show the two events are collectively exhaustive. Understood? Then other concept is, in here, what is the intersection? We take the same example. What is the intersection? What are the elements we can write it as an intersection? No. Are there any no common elements? There are no any common elements. Then only we can draw the empty curly brackets. There is no any element. Then we can say A and B are mutually exclusive. Okay, then we take the 2 or more events. There are no any common elements. We can say these events are mutually exclusive. Understood? Collectively exhaustive, we say based on our union. Okay, if we write the union, that union is equal to sample space, we can say these events are collectively exhaustive. Okay, then how to say the mutually exclusive? Based on the intersection. Okay, then intersection, there are no elements in the common or in the intersection. We can say these events are mutually exclusive. Okay, in the mutually exclusive, then we write the intersection, there is a empty. There is no any elements. Okay. Then other one is equally likely event. It means tossing a coin, getting a head, what is the probability? 1/2. Getting a tail, 1/2. Then what happened, the probability value? Same. That are we called as equally likely events. Okay, then rolling a dice. What is the probability of getting number 1? 1/6. Getting a number 2? 1/6. Getting a number 3? 1/6. Then what is the probability value of each number get? 1/6. Then these we called as equally likely events. Understood? Okay. Then this is the way we can express the probability value. Okay, normally we say that we express the probability value as a fraction. Okay, normally in the fraction there is a numerator and the denominator. Denominator, we express the total number of equally likely outcomes in it. Okay, in the numerator we express the number of favorable cases. Then in here we want to write the probability of A. In here, sample space, there are 6 outcomes. Okay, we need to take the probability value of A now. In here, A, how many outcomes in here? 3. Then we can write it. What is the probability? 3/6. Understood? Okay. Before the break, I will explain another theory. Okay. Then other one is we need to calculate the probability of union. There is a theory we call as additional law of probability. Okay, we call as additional law of probability. Okay, then we need to take the probability value of A union B. Probability value. Okay, then we know. Do you know about the Venn diagram? Yes or no? Or no? In the rectangular represent what? Our sample space. Okay, then this rectangle, when we draw the rectangle, it represents the sample space. Okay, then we have the 2 events, A and B. We represent as a circle. Normally we draw the circle. This represents A event and the B event. Okay, then think this is our Venn diagram. Then this is our Venn diagram. Okay. Then we need to take the union back. How to get the union? Union means whole space. No? Union means this. Then union means all the possible outcomes in the 2 events, A and B. Okay. Then first we take this curve. What is it? A. Okay, then the probability value is we can write probability of A. Okay, then we take this curve. It represents the event B. Then we can add the probability of B. Okay, now cover all the things. Okay, but then what happened to this part? Add to what? Why? We take PA and we take PB. Okay, in the PA, include this. Okay, then we take the PB, again include this area. Then what happened? This common area. Okay, then common area we called as what? Intersection. This intersection part at twice. Okay, then what can we do? We subtract at once. Okay, then we take the PA and we take the PB. Then our intersection at twice. Okay, then we subtract at once. It's okay. At twice, then we subtract 1. Then this theory we call as additional law of probability. This is the way we can calculate the probability of the union using the probability values. Okay. Then other thing is, there is 2 events, A and B. Okay. Then in this example, there is a special feature here. What is it? Then these are 2 different things. In here, there is intersection, but in here, no intersection. Okay, then what we call as these 2 events are mutually exclusive. There is no intersection. Okay, then how to write the union in this one? In this one, how to write it? Then we take the A, then plus we take the B only. Why? We do not subtract the intersection. Why? There is no intersection. We take the A and we add them together. Then that expresses the union. Understood? There are the 2 events are mutually exclusive. How to get the union? Probability of A plus probability of B. Okay? These 2 events are not mutually exclusive. Then we use the additional law of probability. Understood? Okay. Then now you can take a break. Then after the break, we do some summation about the probability values. Okay. Okay. Then moving to the fractions. Do the first one. That's the simply. That's a very simple one. But do first. First way you can answer this question. First you write the sample space and you can get the value. Okay. Then other way you can use the tree diagram. You can use any method. Point is structuralized. Okay. Then we can write all the sample points. Then we can write both time you can get hit. Okay. Then other one is both time you can get tail. Okay. Then first time we get the head, second time we can get the tail. Other one is first time we get the tail, second one we get the head. Okay, then all the possible outcomes for this task. A coin is tossed twice. Okay, it's clear. Okay, then we can answer. Then first one asks probability of getting two heads. Okay, then how to express the probability value? Denominator shows total possible outcomes in here. Then how many possible outcomes in here? 4. Then getting two heads. How many favorable cases in here? Getting two heads. Getting two heads. Only 1. Then we write the probability. 1 over 4. Now clear? Okay. Then the second one asks what? 2 days. What is the probability? 1 over 4. Why? Favorable cases is 1. Total number of cases is 4. The third one are a head and a tail. Then total is 4. Then how many favorable cases in here? A head and a tail. How many? This one and this one. How many favorable cases in here? 2. Clear? Okay, this is the first method you can answer this question. Second method, you can use the tree diagram. Do you know about the tree diagram? Yeah. Then first we draw first. Then the first attempt. Okay. Then toss a coin at first time. Then what are the outcomes you can get? Head or tail. Okay. Then what is the probability value in here? Getting a head 1 over 2. Getting a tail 1 over 2. Yes, no? Okay, then we can use the classical approach to find the probability value. Okay, then this is the first attempt. This one says a coin is tossed twice. Okay, then there is a second attempt. Then we can roll the second. At the second attempt, we can get the head over tail and head over tail. Okay, then the first attempt we can get head or tail. Okay, then think first attempt, if we get a head, second time we can get a head or tail. Okay, then if we get a tail at the first attempt, in the second attempt we can get a head or tail. Okay, then what are the probability values in here? Same, no? 1 over 2. Okay, then first one was getting a 2 head. Then which one shows getting 2 heads? First branch. Okay, getting 2 heads, head, head. Okay, then what is the probability value? How to get that? Half into half. Through this branch, we multiply. Okay, then what is the value? 1 over 2 into 1 over 2. What is the answer? 1 over 4. It's clear? Then other one has 2 tails. Which branch represent 2 tails? Last one. What is the probability? 1 over 2 into 1 over 2. Answer is 1 over 4. Okay. Then a head and a tail. Okay, getting a head and a tail. Then there are 2 chances. Head, tail, tail, head. Okay. Then this branch shows 1 over 4. This one also 1 over 4. Okay, then there are 2 favorable cases. Then we add them together. What is the answer? 2 over 4. Okay. Through the branch we multiply. Branch to branch we add. Okay. Now clear? This is the way we can find in the probability value. You can write all the sample space or you can draw the tree diagram. Understood? Okay. Then do the question number 5. Do you need the time to write it? No? Okay. Then move to question number 5. If you need, you write it. Okay. Finish? Finish question number 5. Okay. The results of an examination conducted into two parts, 1 and 2, for 50 candidates were recorded as follows. Okay. 20 passed in part 1 and 15 passed in part 2 and 18 failed in both part 1 and part 2. If out of these candidates, one is selected at random, find the probability that the candidate passed in both part 1 and part 2, failed only in part 1, failed in only one of the parts. Okay, then the easiest way, you write the answers through the Venn diagram. Or you can write the answers for the directly. Okay, then you can use in the Venn diagram. It's a very easy. Okay, then other way you can same thing. A be denoted by passed in part 1. B is denoted defined by passed in part 2. Okay. Then in here, we can write probability of A. What is the probability of A? Then these are the numbers now. Then using that values, we can find it out the probability. Then what is the probability of passed part 1? How many are passed? 20. Okay, then total number of candidates in here, 50. Then what is the probability value? 20 over 50. Okay, then we can get the value of probability of B. It means probability of candidates passed in part 2. Okay, then how many of them are passed in part 2? 50. Okay, then total candidates are 50. Okay, clear? Then 18 failed in both part 1 and part 2. What does mean? 18 are failed, not part, failed both part 1 and part 2. It means what? Here we find the failed one, part A, part, and from the failed part 1 part and part 2. Okay, then this one says 18 failed in both 1 and 2. Then what does mean? Yeah, complement of A union B. By A union B represent what? Candidate part 1 or part 2. Why? Then we discuss about this part 2. Okay, then it's talking about the past. Okay, then this one says 18 are failed. It means these 18 students are not included in the union. Okay, then we can write A union B complement of A union B is equal 18 over 50. Okay, it's clear. Then what is the union value? What is the probability of now union? Complement is 18 over 50. No? Then what is the union? (32 over 50). Complement means not including the union. Okay, 18 over 50. The total probability is 15 over 50. Okay, then what is the union value? 32 over 50. It's clear? Okay, then we can find the value. Pass in both part 1 and part 2. Then what does mean? Which operation? Pass in both part 1 and part 2. Both mean intersection. Both means common. Okay, then the first one are passed in both part 1 and part 2. We can say intersection. Okay, then question asks intersection. We know the union and the probability of two events. Okay, then we can use what? Additional law of probability. We can use the theory. Okay, how to do that? Then additional law of probability means A union B equal PA plus PB minus intersection. Okay, then union, you know the value 32 over 50. PA is 20 over 50. PB is 15 over 50. Then minus intersection. Okay, these are the fraction, all are 50. Now you can add now. In here 35 over 50 minus intersection. Okay, there is a negative value. We can take into this side. What happened? It will become positive. Then the intersection. Then 35 or 50. Then it will take this side. It will become negative. What is the intersection value? 3 over 50. It means 3 candidates pass both part 1 and part 2. Okay. Or you can use the Venn diagram to get the value. It's easy. The Venn diagram. Okay. This is A. It means past part 1. This is B. Passing part 2. Okay. Then the total candidate is 50. Okay. Then 20 are passed in part 1. We can write 20 in here. 15 are passed part 2. Okay. Then other one says 18 are failed both. Then these 18 candidates, we cannot include these two circles. Then we can write it as this. Okay. Why? These represent only passed candidates. Okay. Then 18s are failed both. Then we cannot insert it here. We can write it this. Okay. Then the 50 total. Then 18 are failed both. Then what is the remaining? 32 candidates. But in here, total value is 35. Okay. Maybe 32, no? But in here, 35. Then there are 3. Then if 3 means what? Passed in 4. Okay. Then we can take 17 and 12. Okay. Then in here, ask intersection of first one. Pass both part 1 and part 2. Both these represent this one. How many candidates? 3. Then 3 over 50. Understood? This is the theoretical way we finding out the value in here. Okay. This question discusses about the path candidate. Okay, then we take the event consider as a path. Then our 18 is talking about the fail. Okay, that is not inserted in the past candidates. Fail, no, both fail. 18 are both fail. Then the at least one part is passed, only 32 candidates. 18 now, 18 candidates failed in both now. Part 1 and part 2. Then the 32 candidates passed at least one part. Okay, then out of 32, 3 candidates passed both. The remaining 21 passed only part 1 or part 2. Maybe a part 1, some are part 2. Okay, 21. Then this 17 means what? These 17 candidates only passed part 1. Okay, then this 12 represent what? These 12 candidates passed only part 2. Okay, then this represent the intersection. Okay, then these three candidates pass both. Then this one represent these 18 are failed in both. Okay, then this 17, these 17 candidates pass part 1, but they failed in part 2. Okay, no? This 17 in here, no? Then this circle represent only candidates pass part 1. Then this 3 is middle. It means these they pass in 4. But in 17 only including the A. No? It means 17 are passed only part 1. Okay, then these 17 candidates failed in part 2. Okay, then what does mean is 12? These 12 candidates passed only part 2. Okay, then they failed part 1. Now, okay. Then failed only part 1. How many candidates failed in only part 1? How many candidates failed only part 1? It means how many candidates passed part 2? Failed part 1 means they passed part 2. Then how many? 2. Now clear? Then 12 of the candidates passed only part 2. Then they failed part 1 only. Now okay. Then how to then you can write the value 12 over 50. Okay? Then the theoretical way, then it means failed only part 1 means passed only part 2. Okay, then passed in part 2 we represent by B. It means B only. Okay, how to write the B only? Is the way. B only. That means B only. Okay, it means A dash. It means not including the A, but these elements are including the B. True? No? This 12 including the B, but not including the A. Now, okay. Then this one is B only. No? Then we want to take the probability value in this area. Okay. Then how to get the value? We take the probability of B, then subtract this intersection. What's the remaining part? B only. Then how to get that? Probability of B minus intersection. B only, how to get that? Probability of B minus intersection. How to get the A only? How to get the A only? Probability of A minus intersection. Okay, A only means this area. This one. Okay, then we take the A, subtract the intersection. What is the remaining one? A only. Now clear? This is the way we write. This shows B only. How to write the A only? A intersection B dash. Complement means not including. Okay, then the A intersection B. Why we put intersection? It indicates the both. They passed part 2. Okay, but they failed in part 1. Both no. Okay, then we put the intersection. Now clear? This is the theoretical way we find in the probability value. What is the answer? PB is 15 over 50. Intersection is 3 over 50. What is the answer? 12 over 50. Correct? No? Okay. Then write the answer for the part C. Failing only one of the part. Okay, not failing both. Okay, only one part. Part 1 failed or part 2 failed. Then which area? Only part, only one of the parts. It means this 17 only failed in part 2. Okay, why this is in here? No? It means this, then they passed only part 1. Okay, then other way we can say they failed part 2. Okay, then these 17 failed only one part. Okay, then these 12 candidates failed, sorry, not the failed, passed part 2. Other way we can say they failed part 1. Okay, then finally we can take the decision. Then these 12 candidates failed only one part. Okay, then these 17 and 12. What is the total value? 29. Then 29 over 50. Okay, then 29 candidates out of the 50 candidates failed only one part. Okay, then these 17 are passed only part 1. It means they failed in part 2. Okay, then these 17 are failed only one part. These 12 also they failed in only one part. Why they failed? Passed in part 2 but failed in part 1. Okay, then 3 are passed both. We cannot get these 3. Okay, 18 we cannot get. Why? 18 are failed both. Okay, then what is the answer? 29 over 50. Okay, then theoretically where we can write one part, then A intersection B dash plus A dash intersection B. This means A only, this means B only. Okay, then A only is 12 over 50. This one is 17 over, but it does 29 over. It's clear? Okay. It's clear now. It's the way theoretically where we can write the answer for the probability questions. Okay. Then do the question number 6. If you have any questions, ask from me. Okay. These are the basic things. Okay, then there we will discuss the other circuits. Okay, then there is the joint probability, marginal probability, conditional probability, total probability, low variance clear. Okay, then these are the advanced concepts. Before then study these basic things. Okay. Okay, let's discuss. Then this one says probability of A 0.39, probability of B 0.21, union is 0.47. First one asks A no, B will occur. What does it mean? O means O means A O B means what? Union. O means A O B means at least one of the event will be occurred. A O B. A O is the English word for the union. Means union. A O B union. Okay. Then what is the hint word for the intersection? What is? Both means what? And. Okay. A O B means at least one of the event will be occurred. O means A O B means event A will occur, or event B will occur, or event A and B both will occur. That means O or union means that one. Event A will occur, event B will occur, or both will occur. That means O. Okay. Then now say what is a no? No are. Now you have done it. O is clear now. O means union. A will occur, B will occur, or both will occur. Then what is the meaning of the no? Completion of the O means union. Then no means what? Complement of the union. In this question, ask calculate A no B. It means complement of the union. Okay, then how to find the complement? 1 minus union. Why? Always total probability value is equal to 1. Total probability. The maximum values we can get as a probability value 1. Lowest value is 0. Then the total probability value is 1. Okay, then we take the 1 minus union value. We can get the complement of the union. Okay, then in the Venn diagram we draw. Okay, then it represent the union. Okay, then the complement means this area. This rectangle represent the sample space. Okay, then probability value of this whole rectangle is equal to 1. Then we subtract this part, we can get the complement of the union. Okay, then now you can write the answer. 1, then we want to find out the union. No, there is the answer. 0.47. Opposite word of here is a no. Neither A nor B is no. It means even A will not occur, even B will not occur, and this both events will not be occur. That means no. Okay. Then part B is talking about both A and B will occur. What does it mean? Both means and means what? Intersection. Common thing. Okay. Then we find it now the intersection. Right, the intersection. Okay. Then we using the additional law of probability. Union is 0.27. Probability of A is 0.39 plus 0.25. Okay, that's a simple equation. Then you can get the value in here 0.60, 0.27. Okay, then we take the intersection this side, it will become plus. Then 0.60 minus 0.27. Okay, intersection is 0.13. What is it? Now tell me only every number means what? Only every number. Only A. Okay, it is not included in the part in the B. Only A. Then how to find it? Take the probability of A, subtract the intersection. Only A. Okay, then intersection means both. Common area. Okay, then we take the A, we subtract the common. Then we can take the only A. Okay, then how to write the only A? Only A we can write A intersection B dash. A only. It's clear enough? Do the question number in here, question number 2 and question number 3. Not the question number 3, question number 2 and question number 4. 2 and Finish question number 2. Okay. This one says a contractor will get a building contract 2 over 3. Probabilities that he will not get an electric contract are 5 over 9. Okay. Then first we define the letters. Then the A is he will get a building contract. B is he will get an electric contract. Okay. Then first one says 2 over 3 is the probability value. He will get a building contract. It means TA is 2 over 3. But other one says he will not get an electric contract is 5 over 9. He will not get it. Okay, but we want to, he will get an electric contract. What is the probability? 4 over 9. Okay. The question is given the complement of that event. Okay, then 1 minus that event, we can get the value for the event. Okay, then other one says getting at least one contract is 4 over 5. At least one means he will get a building contract, he will get an electric contract, or he will get a both. Then at least means that one. Okay, at least one. No? The lowest is he will get only one contract, at least. Okay, then he will get a both or electric or building. Okay, then what does mean? In the probability wave, at least means union. Okay, then the union is 4 over 5. At least is another hint word for the union. Okay, then question asks he will get both. It means both intersection. Okay, you can use the additional law of probability. Then you can get the value for this question. Okay, what is the answer? Then union equal PA plus PB minus intersection. This is the law, additional law of probability. Okay, then we substitute the value 4 over 5, 2 over 3 plus 4 over 9. Okay, then take the intersection in here. Then plus these two values, then subtract the 2 over 5. Okay, you can use the calculator and you get the value. Okay, you can write it as the value and the ratio, not the ratio, decimal value. Okay, or you can solve it with this. You can take the 45, then 30 plus, 20 plus, 36, 14 over 45. Okay, or you can convert these probability value to the decimal value. You can get the value through the calculator. Okay. Finish. Then question number 4. First one asks A intersection B dash. Increase one. A intersection B dash. A intersection B dash means what? A only. A intersection B dash. B dash is not including the B. Okay, then what can say? A intersection B dash means A only. A dash intersection B means B only. Okay, then how to calculate A only? Probability of A minus B intersection. Okay, then have it. Finish it. That is the answer. 0.29. Okay. And the second one asks A dash intersection B dash. A dash intersection B dash. Intersection means always intercept the both. A dash means not including the A. B dash means not including the B. Okay. Then it means complement of the union. Right? A dash intersection B. Okay? It means A will not occur and B will not occur. Both. Okay, then these not represent the circle. Okay, then the remaining part of the rectangular represent that one. A dash. A will not occur. B dash means B will not occur. Intersection sign means both. And A will not occur and B will not occur. Or we can say both will not occur. Okay, both will not occur represent as the remaining part. Means complement of the union. In previous question, there's part 1 and part 2. Then there are 18 candidates are failed both. Okay, it means complement of the union 18 are failed. It means that they failed both. Okay, the same as okay, both will not occur. It means A dash intersection B dash. Yeah, the way we can write complement of the union. Okay. Equal to complement of the union. Okay, how to get the value? 1 minus union. Okay, A dash intersection B dash. Then this is the proof in here is B and this A. First part says A dash, no. A dash means A will not occur. It means this area is the A dash. Okay. Then other one says B dash. B dash means not including the B. B will not occur. B will not occur means this one and this one. Okay. Then what is the mathematical operation? Sorry, not the mathematical. What is the rule of operation in here? Intersection. Intersection means both. Okay. Then what are the both area? Only this area. Then two colors. Okay. Then this area. It means complement of the union. Okay. What is the answer? First you finding out the union, no? And we finding out the union. Okay. That's the union value. Let's say the union 0.65. Okay, then what's the complement of union? 0.35. Now here, okay. This is the last one, okay? This question number 5. And next section is the probability distribution, normal distribution, those things. The foundation for them. Okay, then normally practical calculate those things. Okay, but the normal distribution, then probability distribution is practical we use. Okay, then we need to do the statistical analysis. First, we identify if data set is a normally distributed or not. Based on that, we select the which test is appropriate. In the statistical way, we have two types of tests, parametric one and the non-parametric one. Okay, then parametric test we can use only for the data set is normally distributed. Okay, and the data set is not normally distributed, we cannot use a parametric test. We move into the non-parametric test. Then every test has the parametric one and the non-parametric one. Okay, then first thing is we have the data set for our analysis. First you check whether these data sets are normally distributed or not. Okay, then we using the software, we can get the idea about it. We do not manually calculate it, and we cannot then we do not say this is normally distributed or not. We have the test for testing the normally distributed or not. Okay, then through our data. In this object, then we will do, then we have get the knowledge about what is the normally distributed. Okay, then which kind of data we need to do the normally distributed. Okay, then is the idea. Okay, then first day I say then this is object, then always I will give the theoretical part. Okay, then you get the knowledge and your side you get the how to do that in the practical scenario. How to use these theoretical concepts in our practical scenario. Okay, then we have our other remaining parts in 3 or 4. Okay, then end of this series, okay, then you can be in your side, you can do the analysis for the whole data set and take the final decision. Okay, this is the process now. Then now you can get the idea about how to collect the data. The first step is okay. Then the second step, then now you have the idea about the residual analysis. Okay. Understood? Then end of this series, you have the idea about how to do the descriptive part and the information part both, how to do the analysis and the data set. Okay, that is the objective of this session. Okay, do the manual calculation and find the probability value. One day is the theoretical. Okay, then therefore I give the assignment number one to do that. The practical one. Okay, then you can get the idea about how to do the reality in a practical way, how to do the analysis. Okay, don't need to quiz and those things will do the equations. Relevant to you now. Okay, then this is the objective of this pixel statistic. Okay, then finally you have get any data set. You can do the analysis for this n data. The final year research very easy to do. This is what the done. Finally, the research. Research means first you identify the research questions. Okay, then you develop the objectives. Finally, output is then fulfill the objectives to get finding out there is a relationship or not. Okay, there is impact or not, those things. Okay, then the very important thing is the research is do the analysis part and make a decision, make a conclusion. Okay, then using the statistical way, we can find out the decision about our topic. Okay, conducting research means we finding the answer for that particular question. Okay, then normally students, then undergraduate students will the research about the finding out the impact or relationship, those things. Okay, then through this research you collect the data. Now you have the idea about how to collect the data. What kind of data do you need? Okay, in your idea about the research project, then think first you identify what is the objective of the study. Then depend on that you can see that. Then we want to find out the primary data or the secondary. The first two sessions we discussed. Okay, then when we need to collect the primary data, when we need to collect the secondary. Based on the data, then our analysis is different. Okay, then we do the test appropriate your objective of the risk. Okay, then get the idea about it. ඒක තමයි මගේ සබ්ජෙක්ටිව් එක මේ සෙෂන් කාර්යයේ එක සබ්ජෙක්ටිව් එක්සෙම්පෂන්ස් ලෙවල් එකේ ඉඳලා මේක දෙන්නේ ඉන්නේ ෆස්ට් ඉයර් සෙකන්ඩ් සෙමිස්ටර් සබ්ජෙක්ට් ඒක දෙන්නේ ඒ හේතුව නේද ඒක ගන්න ෆයිනල් ඉයර් රිසර්ච් එක ගන්න ප්‍රැක්ටිකලි ඔයාලා උද්‍යාන if your target is be accountant, I think. Okay, that's when you need to do that financial analysis. And that is very important. Nobody in the working in online cooperative sector. And you have the data set regarding the sales or something. Okay, then you can analyze and you can get the idea about your profit to revenue to. One is that the report understood the objective of this house. Essentially, too much basic concepts all over the and these people analyze particular scientific question about your data set means Okay, then what is the type of variable? What is the level of measurements in here? Okay, lines. Okay. The biology proctor has two research assistants. The probability that all of two assistants will be absent on any given day is 0.08. Okay. Then the younger one will absent on any given day is 5%. The probability that they will both absent is 0.02. Both means intersection. Both of the assistants will be absent plus 1 hour. Very easy to both will be absent, but not 0.02%. Okay? At least one of the assistants will not be absent. At least means you need. Okay, but these are at least one of these assistants will not be absent. Another one are only one of these two assistants will be absent. One of A means A only and the B only. Get the sum. Okay. At least one of the sorry. Only one of the two assistants. Okay. What is the answer for the part 2? Is one of the two assistants will not be absent. Is one of the two assistants means one of the younger assistant will not be absent, or the one will be not absent, or both will not be absent. Okay. Then what is that? Then what does not occur in here? Both will be absent. This will not occur. It will not occur. Both will be absent. But at least one of the assistant will not be absent. Okay, it means younger one will not be absent. Or all the assistant will not be absent. Or both will not be absent. At least is that one. Okay, but it's not included here. Both will be absent. Then what is the answer? Complement of the intersection. 2% is the probability value. Both will be absent. 2%. Okay. Then what is the at least one of the assistants will not be absent? 98%. 0.98. Yeah, the rest of the part explain. A will not be absent, B will not be absent, 4 will not be absent. Okay, then A will not be absent if present. This part, B will not be absent this part. Then this says A not A only. It means B will be absent. Then this means A will be absent. This circle shows. Okay. Then this part means only A will be absent. It means B will not be absent. Understood? Then this part shows only B will be absent. Other way we can say only A will not be absent. Then this area and this area. Then this area shows both will not be absent. Okay, then that's the meaning of the at least one of here. Okay, then what is not included here? Both will be absent. Okay, then we can take the intersection. Then subtract from 1, we can take the value of that probability. Understood? Clear? Okay, what is the answer? 0.98. Okay, then part 3. Only one of the two terms will be absent. It means A only and B only. Then this part is A only only A will be absent. This part is only B will be absent. Okay, then check the sum. What is the answer for the part 3? Zero point 0.09. One of the assistant may be as scenario discussing about the absent trade. Union means O. O means A will be absent or B will be absent. If either both will be absent. Please follow the answer. Yes, at least means both will be absent and none. And that means you will. Intersection means O. And we have one distance. One distance will be absent. At least one of the answers will not be yes. At least yes, the other one is it's one. ini kok urusannya mungkin mau di mana itu apa yang kita ingin sebenarnya yang penting kan kalau di kita orang itu seperti ini itu kan dari sama itu ada guru yang tapi kalau dia bilang pas kerja media ada dan kemarin kita kerja di dengan dan istri kita juga lagi tapi aku bilang orang itu presiden nanti dia segera kerja ini ya ada teman kita pas kerja dari juga kami di sedang dengan kita yang sibuk dengan yang kita dapat sekian orang yang juga punya pada kembali ke sosial media. Jadi makanya kita sekarang ini jalan tapi bukan kita sendiri kalau punya masing-masing sebenarnya tidak ini kalau itu desanya kita tahu sini kita lihat tidak mesti dan itu yang all the time kita kalau kita sendiri dan saya oleh sebenarnya kita itu hasil then first you go then I will upload the guidelines to the elements and then go through the assignment sheet then you have the thing to upload your then only you upload it as a PDF format it's not uploading the image you it's then uploading the PDF there are the links it goes to the link and upload the link. If you have any questions regarding the assignment, you can mail. Okay, this is the number. For me to guys something to the file. It's a good idea. I make that you can make it. I made this in the file. It's very problem. You can make it.